Hello.
Am I audible?
Yes, sir, we can hear you. Can
Okay,
you share your screen once just to check the video?
okay. Sharing my screen. Just
Yes,
is
sir,
it
we can see it.
okay? And I think the full screen is also visible, right?
Yes, the full screen. Yeah.
Okay, okay.
Start करें? Okay, good afternoon to all the participants. Welcome to day 4 of our 5-day FDB program. We will shortly begin our first session of the day. And for this session, we have with us Dr. Arindam Sarkar, who will be delivering his lecture on zero knowledge gossip learning, shaping the future of private AI. Before he begins, a few words about our distinguished speaker. Dr. Sarkar is presently conferring his service as an assistant professor and head of the Department of Computer Science and Electronics at Ramakrishna Mission Vidya Mandir in Belur. He completed his PhD in engineering from the Department of Computer Science and Engineering, University of Kalyani in West Bengal, under the Innovation in Science Pursuit for Inspired Research Fellowship of the Department of Science and Technology, Government of India. He secured university first class first rank in MTech in Computer Science and Engineering from the University of Kalyani. He has also earned a Master of Computer Application from Vishwabharati University in Shantiniketan. Dr. Sarkar had secured second rank in the West Bengal College Service Commission for General Degree Colleges. He was also University First Class 10th rank in Bachelor of Computer Application from the University of Bardhaman, West Bengal. He has over 155 research publications in various SCI and Scopus Index international journals with high impact factors. He is an accomplished researcher with collaborations spanning 31 international and 9 national institutes. He is a regular contributor to leading English newspaper. He writes extensively on cybersecurity and AI. His research interests encompass neural cryptography, GAN cryptography, cybersecurity, federated learning, deep learning, machine learning, generative AI, and soft computing. Currently, he is working on a major project sponsored by the Indian Council of Social Science Research, Ministry of Education, Government of India. We are very happy to have such a esteemed figure among us, and we are sure that you will enjoy this session and learn from it. So, without waiting too much, let us hand over the reins to Dr. Sarkar. Sir, over to you.
Thank you so much for your generous introduction. Now I'm sharing my screen. Okay, is it visible?
Yes, sir.
Okay, okay. Okay, very good afternoon to all of you present over here. Om Namo Bhagavate Shri Ramakrishnaya Namah. Okay, this is my college. My college name is Ramakrishna Mission Vidya Mandira. It is in Belmont, and it's a dream child of none other than Swami Vivekananda. And the name Vidya Mandira is actually coined by him. These are my different publications. And I would like to start with the most vital problem in today's society, that is cyber security, data accessing, strange conditions. We all know that whenever we are trying to transfer some data from one country to another, means cross-border transaction, then we need to think of the act that is called GDPR. It's called General Data Protection Regulation Act. This act was passed by the European Union, EU, in the year of 2016 and is went into effect on May 25, 2018. Now our India government going to launch DPDP Act. Already it's been passed in our parliament in previous year, 2023, in the month of August, and we are eagerly waiting then when it's going to be implemented. This DPDP means this Digital Personal Data Protection Act. The question is here, why I'm showing all this information in my first slide? Because as a computer scientist, whenever we are doing any research or any kind of experiments, the first and foremost thing that you need is data. So without data, we can't do anything, right? So from our school level or college level books, we have already learned data structure, DBMS, big data. So everything is about data. And we are saying that the data is right now
Recording
oil.
in progress.
Data is a oil. Data is a gold. So we are saying data is everything for us. But the problem is that we do not know how to handle this data. We have enormous amount of data, but the problem is that how to maintain all this data, how to put this data across different organizations. Not only that, how to extract revenue out of it. So what will be the scenario? What will be the best practice to save all this data, right? And the last one, but it should be the first one, how to secure your data. And another thing is missing in the slide. That is what data you can access. So as I mentioned, that we need data, otherwise we can't do anything. But whenever we are asking for data, then there is a rules and regulation that this kind of data you can access, this kind of data you can't, right? And in today's world, everyone is talking about machine learning, deep learning. Whenever you're talking about ML or DL, we need huge volume of data. So who gonna give you data? Suppose you are doing any research on healthcare data. Do you think any hospital going to give you all their data? I think no hospital going to share their data with you, because there is a patient privacy, right? So if we don't have data, how to train our model? That is the big problem. Now, whatever we have done in our machine learning, deep learning, maybe 1 year before or 2 years before, we do not have this DPDP Act. But when India government will implement this DPDP Act, think of the situation. You will not be able to access anyone's data. You need to take permission. And there is a clear distinction between the private data and the public data. What you can with that data, after using that data, what will be the next step? You need to erase the data, right? So these are the different problems. Now, whenever we are talking about data, two terms are very much associated with data. It's called data privacy and data security. Privacy means it's the individual rights to control personal information. So how you can control your personal information? Where from you collect the data? How will you going to use the data? How you are going to share the data? How much information you are going to share? So there should be a levels. I think already we have learned public, private, protected, different access specified in our different languages. It's maybe quite reasonable technique. So using GDPR or DPDP, whenever you are accessing data, you need to ensure that from where you have collected the data, you have the proper permission and what you are going to do with that data. And whenever we are talking about data security, first thing is that how to protect the data. And we all know about data security because we need encryption algorithm. We need some robust algorithm to secure our data. We can prevent the misuse of our data. We need to maintain the data integrity, availability, and the data confidentiality. So this is the clear distinction between data privacy and data security. Privacy means which part of the data to be shared. You need to impose a control, right? Whenever I'm talking about this GDPR and DPDP, GDPR is very stringent rules than DPDP. I can say that DPDP is our India government's Digital Personal Data Protection Act. This DPDP is a subset of GDPR. So if we follow the GDPR, I think we can cover this DPDP. Now, how to maintain this data privacy and security is a very much alarming issue because we are not thinking how to design our algorithm from the inception so that we can ensure data privacy and security at the time of designing our algorithm. I'm repeating once again. At the time of designing our algorithm, we need to think of that whether we are preventing or we are maintaining the data privacy, we are preventing different unauthorized access. Suppose we are designing any machine learning algorithm. So whenever we are designing any machine learning algorithm, then we need to think that what will be the learning procedure so that we can prevent the privacy, right? We can ensure the privacy, we can prevent different type of attacks. And what is security measures for ML kind of algorithm? Whenever we are actually doing different analysis on the data, how many of you secure the data before doing ML algorithms, before applying ML kind of algorithms? I think this is not clear to you. I'm repeating once again. Suppose one heart disease data set is available to me. I want to analyze that data set. So I have a huge amount of different kind of algorithms. I can use the most suitable algorithms on heart disease data set. But who going to give you the guarantee that whatever the ML or DL algorithm you are using, basically you are using some packages. All the codes are written in the packages. Different languages are available. Whatever maybe the languages are right now you're using some packages. Code are pre-written. So who gonna give you the guarantee? Some hidden codes are written there that are responsible for leaking your data. That means we cannot run ML or DL or any kind of algorithms on the plain text data. But right now, all we are using this kind of algorithm on plain text data. So what are the different shortcomings, right? So different shortcomings means in GDPR and in DPDP Act, there is no specific guideline for AI-based cyber attacks. Now, there is a lack of specific provision of AI-based cyber attack. There's an insufficient mechanism for identifying AI-driven threats. How will you be able to identify that this particular threat is AI-driven threat, right? Because the adaptive nature of AI-driven threat. I will show you some practical example, then you will be able to understand that how a particular malware adaptively increase their visibility or increase they're changing their signature so that so-called antivirus or defending softwares will not be able to identify that this one is a malware. Now, this is a snapshot of our DPDP Act. The clause 3C2 is saying that, just read through the last two lines of this slide, that if any individuals, maybe whenever he or she writing any blogs, this can be treated as a public data. Now, the question is that if in his or her blogs, if anyone explicitly providing some information which are known as public information as per DPTP Act, from that public information, if anyone can able to generate the identity of that person, then this public data is not public. It will become the private. So which one is public data? Which one is private data? The definition is blurred right now. The data available in the social media account, we are saying that all are public information. But from that public information, if anyone can be able to extract your date of birth, maybe your age, maybe some other information that can be used or misused, then this public information is not safe. So, which is purely public information can be used for any reasons. Right now, India AI missions are using public data available in the social media account to create a global data set. Due to the DPTP Act, you are not be able to access anyone's data. That's why what India government is doing, they are launching India AI mission, where they are actually trying to design different data set. How they are trying to design different data set? After accessing the data of your social media accounts, which are known as public data. But my question is here, from your public data, if your some vital information can be inferred, then this data should not call your public data. This data becomes the private data. So there are different AI-based attacks. Deepfake technology, AI-driven phishing. In a deepfake technology, you all aware of this deepfake technology, where different realistic videos can be made using different CNN or different generative AI tools. And CEO authorizing fake transaction is one of the example, right? Different AI-driven phishing attacks are there. You may not aware of the thing that this particular AI-driven phishing will guide you where to put the phishing link in your text. What will be the suitable portion of your text where to put the phishing link? And automated vulnerability exploitation. It actually scans your defending software, your antivirus, and then it change its signature so that it can bypass your antivirus. Think of the situation. The malware can analyze the algorithm of your antivirus, and then it can change the signature. After that, your so-called high-profile antivirus will not be able to understand that this one is a malware. Now, you could have asked me how. It's not an easy thing to do. Yes, it's not an easy thing to do. But how this particular malware is doing? Malware is actually sniffing your information. Without doing any harmful activities, it's actually listening your port. And it's actually observing how your antivirus react, how your antivirus can identify a signature of a malware. Then it will actually improving itself so that it can bypass the antivirus. This so-called attack is known as zero-day attack. So your antivirus is not prepared for preventing this kind of attack. Now, data poisoning attack. It's a very, very interesting attack. Suppose in your machine learning or deep learning, you have a data set and you are confident that you have gathered some data. You are confident that data have different features so that I can get insight from data if I can be able to use the machine learning algorithm or deep learning algorithm properly on that data. But have you ever tested your data set that your data set is actually poised or not? Is there any poison attack on your data set? How will you believe on your data set? How will you believe on your historical data? So the attacker can manipulate your data set that actually hamper your ML or DL training, right? And different social engineering attacks are there. I think you are aware of that thing. These are my different write-ups on different kind of attacks that are going to be take place in 2024. And here I have especially talked about generative AI-based cyber attacks. This is another article of mine where I have talked about that you are thinking that you have locked your other profile, you have generated your virtual ID, and you are quite safe from Aadhaar Enabled Payment System attack, AEPS. But sorry to say that this VID will not be able to give you that much of security. That's why I think you have heard that my Aadhaar is already locked. Then also this much of amount already been deducted from my account, right? So for that, I have written that how it can be possible. And the different scams that can be performed using the instant loan offer, right? Different social engineering tactics and how a particular malware can be present in this loan app. You are downloading your app from different app store. This you are thinking that, okay, I will not download any apps from any unauthorized sites. I'm downloading any apps from Google Play Store, maybe some different platform. Then also, the algorithm is actually scanning for Google that, okay, these are the legitimate apps. I'm bypassing the algorithm, and some hidden elements are present in that particular apps. If you install Uno apps, Uno apps is asking for the first time, Uno apps is asking for your call log access. Why? If a legitimate apps accessing your call logs, then how can I distinguish that a malware or the apps which is not legitimate, which are accessing this kind of different access, these apps are actually escalating permissions. So why this particular apps needs our call logs? So for this DPTP Act, the rules going to be very stringent. That what is the purpose of your apps? If this is the purpose of your apps, you can't ask for anything else, right? So I have talked about different cyber attacks, different AI-based cyber attacks. And I'm saying that only one thing is a solution. We need to upskill ourselves. So upskills today for a safer tomorrow. Now, how to upskill? The first solution should be educate the people about the threat. Second, it's adapt processes to support resilience. And obviously, we should ensure adequate defense are in place, right? We all are talking about cloud security. We are thinking we're using blockchain. We are saving our data in a cloud. We are safe. Sorry to say that whenever you are actually keeping your data in a cloud, that means you are actually keeping your data in your friend's hard disk. You are keeping your data in your friend's hard disk. If you have a faith on your friend will not going to do any kind of misuse of your data, you are actually believing on your friend. Same thing here. You're believing on a cloud. You are saying that no, cloud will not going to misuse my data. Same thing. So we are in a myth that we have a blockchain, we have a cloud. Then please visit the dark web. Please visit the dark web. Please visit the maybe the different sites there. how many cryptocurrencies are there, and what are the data are there. Whatever the internet right now we are using 4 to 5% of the internet. 95 to 96% of the internet are actually dark web. Now, whenever we are using different machine learning algorithm, first thing we need to think of, as I mentioned, that what is the validation of the historical data? Before working in a data set, you need to validate your data set. You need to check, is there any chance of injecting some malicious data in your actual data set? And then you need to perform different kinds of tuning. Otherwise, you will not get that much of accuracy. Just using 80-20% split and using some kinds of cross-validation method or feature engineering methods not going to give you the full potential of that ML algorithm. Rather, you need to find out what will be the best setting to get the best insight out of that data set. So, the next topic of today's lecture should be Sabka Data, Sabki Suraksha. So, right now, this data security is a very much important thing in today's world. Whenever we are talking about machine learning, suppose I want to build a machine learning model where I want to analyze all the hard disk data set of maybe for Indian people. Then what will be the situation? We need to buy a cloud where we need to save all the data of all the hard disk data of our Indian citizens, right? So what about the data privacy? And whenever you are transferring the data, what about the data security? So I have a solution. This is called federated learning. This federated learning means this is another article of mine where I have talked about the federated learning. This federated learning means we are not actually accessing the data set from the clients. Rather, we have a client server model. What we are doing as a server, if I'm a server, I'm sending some model to my clients. I'm sending some model to my clients. I'm asking my clients that you have a data set. That means you have a local data. You need not to transfer the data. Rather, whatever the model, maybe the model name is decision tree. So I have sent you a decision tree model. You just use this decision tree model on your local data set. You just use this decision tree model on your local data set. And then just try to transfer only the model parameters. Don't transfer me your data. Don't transfer me your accuracy, precision, F1 score, recall, anything, any information I do not need from you. I need only the model parameter from you. So I'm accessing the model parameter from clients. After accessing the model parameter, the server trying to average that model parameter. Server has a global model. Server has a decision tree model. But that decision tree model never experienced any data. I'm saying once again, data are actually stored as a client, as a local data set of a client. So data are actually reside in a client side, and clients are only sending the model parameters. The server is actually aggregating the model parameters. And then it's sending back to the client. In this way, the model parameters are get updated. And after the final step, the server model will be built using this average model parameter without using any data set. So here we can build a global model without accessing the local data set. So we are not accessing any data from clients. Here we are actually maintaining the GDPR regulations or DPDP regulations. So we are not centrally allocating the data. Rather, this is known as distributed machine learning, right? So here we're ensuring the data sensitivity, because data is still residing in the local site. We can reduce the data breach, and also it compliance with the GDPR and DPDP. Here, there is a privacy regulation, user consent, which data to share and which not, right? And we can, using different devices as my clients. Maybe a smartphone can be act as a client. Maybe a tab can be act as a client. Maybe a i7 or i9 machine can be act as a client. That means I have heterogeneous gathering. I have heterogeneous infrastructure as a client. So how to run a particular algorithm because of resource constraints. So due to the resource constraints, what we are doing, we're analyzing the resource availability. How much resource are available for that particular client device? After analyzing that, we are generating our ML algorithm runtime. So our ML algorithm will be unfolded runtime after analyzing the resource availability at the end client, right? So we are saying that ML for every device. Look at here, the code is depicted that we are first gathering the resource information, and then we are actually developing our ML model. You could have asked me that, what do you mean by generation of ML model? Why are you saying that ML model will be generated at runtime? As I mentioned you, that we need to thoroughly analyze at what will be the best setting, best hyperparameter, best feature engineering algorithm, best split ratio for analyzing the data set. For doing that, we need huge amount of computation. We need huge amount of power. So if a device has a limited power, then the device will not be able to analyze these steps. So for that device, we are actually customize the number of steps that device should analyze to get a handsome accuracy. This FL algorithm, this federated learning algorithm, is not safe one, because here I have already mentioned that we are not sharing our data set with the server. So we have already implemented the data security here, but we are sharing some model parameters. What do you mean by model parameters? For regression algorithm or for linear regression algorithm, maybe if I talk about linear regression, the bias and weights are the model parameters. I'm sharing just bias and weights. So all the clients are sharing bias and weights of their respective linear regression model. Who gonna give you the guarantee that the attacker will not manipulate the data? That is called data poisoning attack. That means whatever the model parameter are being shared between this server and client, the model parameter can get tampered. And when the particular server is actually aggregating all the model parameters, then also what will happen? Anyone can inject some malicious or some noise, add some noise in that particular server. So it can hamper the aggregation operation, right? So if they can hamper some aggregation operation, then what will be the problem? The problem is that the model parameter updation will be in a problem. So it will be affected. So how we can resolve the problem, right? So for that, we have a solution. But right now we have to think of that how generative AI are actually performing different kind of attacks, and also how we can prevent them. The tagline should be Suraksha Tutegi and Data Lutegi. So this is one of my article about generative AI based social engineering attack. where I have talked about how generative AI can be used for uh, designing different kind of attacks, like Wi-Fi attacks and different kind of attacks. I think all of you know that ML is a subset of AI, and neural network is a subset of ML, not DL. And DL is a subset of neural network. And Gen AI, generative AI, is a subset of deep learning. So here we have two modules in generative adversarial neural network. Why I'm talking this? Because whenever we are designing any malware, or we are preventing any malware, the problem is that we do not have sufficient realistic data. Do you think that number of crimes actually been occurred and number of crimes which are recorded officially, both number are same? No. So if we do not have huge amount of data, then how can we process? How can we train our ML model? So here, generator and discriminator, there are two modules present in generative adversarial neural network. What are the tasks of generator? Generator tries to generate some output based on the input fed it into it. So I have fed it one realistic data set having only 1,000 rows. So I have only 1,000 samples of a particular crime. That particular data set being fed to that generator. And also some additional input. That additional input is called as noise, is added. So there are two inputs. One is realistic data set with minimum amount of data, and another is noise being fed to the GAN. Now, generator tries to generate new data using the noise and the given input data set. Why noise is essential here? Otherwise, it will generate the same data fed to it. Noise is actually give you that essence so that you can generate new kind of data. And that data should be correlated with the input data set, whatever actually supplied to that generator. Who's gonna check whatever generator generates that is actually correlated, highly correlated with the actual data set? Another module is there, discriminator. Who takes this responsibility? Discriminator will take this responsibility to check whatever the generator generates, it actually correlates with the inputs given to it or not. So there is a clear distinction. Whatever the generator generates, it's a fake data or real data. If discriminator able to distinguish that generator, whatever you have generated, I am thinking it's a fake one, then discriminator wins, generator lose. This is like two-sum games. So what is my aim? My aim is that generator should learn the hidden patterns present in my input data very well, so that whatever data generated by the generator should contain all the features, and discriminator fails to distinguish that it's real or fake, so that discriminator passed the data and labeled it as real data. If discriminator fails, if discriminator labels this data is a real, I am considering only that data and I'm adding that data in my mother data set. In this way, I'm augmenting my data set so that I can be able to train my model with huge amount of data. The data generated by this generator is known as synthetic data. These are the different codes are written here. Using that code, you can generate the data. Look at the graph. Here the orange line is depicted the generated data, and the sky color depicted the real data. This is the histogram data distribution. Okay. So as I mentioned you that whenever we are talking about that, when we are in a situation that we can't go with classical ML because we can't access the pupils' data. That's why we have moved to the federated learning, right? In federated learning, we have talked that we are not accessing data. Only we are accessing some model parameter. Think of the situation if server get compromised, because here server has a responsibility to average the model parameter, to send back the model parameter to the client, and overall arrangement or overall management of that particular federated learning setup. If server get compromised, then what will happen? That's why we have moved to the next version. It's called edge learning. In edge learning, we are not talking about client-server relationship. Here we are talking about peer-to-peer relationship. That means it is purely decentralized mechanism. Federated learning was not purely decentralized mechanism because there was still client-server model, though we are not sending our data to the server, right? So here in edge learning, we are actually same thing. We are transferring our model parameter not to the server, but to my neighbor, which is just like a ring topology or like a mesh topology. But the problem is that the edge device has a limited power, as I mentioned, but I have already given you a different context. Means the edge device has a limited power. Due to that, they are not capable of processing your data set using different combination or different settings of that ML algorithm. That was the problem there. But here is the problem is that how your edge device, maybe your smartphone, maybe your IoT devices, will be able to prevent the AI generated attack, because it has a limited capability or limited processing capability, right? So that is the problem. As I told you, that generative AI can perform different kind of attacks. Look at here. If I asked our ChatGPT model, or maybe Gemini, or maybe Meta, to write a phishing email for me, do you think that Meta, Gemini, or the ChatGPT give you the phishing email? No, because the content viol policy. So it will give you the error message that it will violate our content policy. Don't worry. I have a solution for you. Warm GPT is there. This Warm GPT is specially designed for this, to generate this kind of malicious code. This is a haven for hackers. If hackers want to generate a malware, if hackers want to generate a AI-based maybe phishing link, it can give the code. There is no content policy. If you are not satisfied with the Warm GPT, don't worry. I have another solution for you. This is called Wolf GPT, right? So it has no restriction. So if you want to generate any business compromise mail or any high-level attack, it will give you the code. If you are not satisfied, I have another option. It's called Fraud GPT. And the very interesting thing of this Fraud GPT is that it will indicate where to place a malicious link, and it's also updated every week or two, right? So this is actually criminal GPT at your service. This is one of my article published in the Statesman, when I have talked about ChatGPT 5 and artificial general intelligence, AGI. So the most awaited topic of my today's lecture is gossip learning. As I told you, that classical ML will not be a solution. I have moved to the federated learning. And I also give you the problem of federated learning. I have moved to the edge learning. And I have already mentioned you that this edge device do not have that much of capability to prevent this AI-based attack. That's why gossip learning. So gossip learning का साथ cyber सुरक्षा का विकास. So what is gossip learning? Gossip learning means just like our day-to-day gossiping nature. That means it's a complete decentralized ML approach. Here, actually, we're exchanging the model parameters. Same thing for edge learning, as like as predator learning. We're sending the model parameters, right? Whenever model parameters are being shared, it's shared in a peer-to-peer network. And not only that, how much information I will be able to share, there is a restriction on that, right? So this is the gossip learning framework where information are actually sharing periodically. We can merge the information. We can update the information. What is the essence of this gossip learning? It means, suppose one of the node already experienced one zero-day attack, and that node was not prepared for the attack. As I mentioned to you, that for the zero-day attack, how your antivirus will react, right? So antivirus will not be able to protect you from the zero-day attack. So after experiencing the zero-day attack, now the models actually updated itself, right? Due to the updation, the experience in terms of model parameters are being shared with the peers. Look at here. Whenever we are talking in our community, we are sharing our experience. We can't share the actual situation because only I can experience that situation because I was there. But I can share the experience with you. And after sharing the experience, what you can do? So you can learn from that experience, right? So you can update yourself. So the node which not yet experienced the zero-day attack can update after getting the experience from a node which already been attacked, right? So here, there are different methodologies are there. I can periodically update a machine. It's called synchronous gossip learning. Also, we can update a machine asynchronously, right? So this is the algorithm of gossip learning. I'm not going to give you the description of each and every line of the algorithm. It will be a boring thing. So how gossip learning supports the GDPR and DPDP compliance? So limited personal data sharing between nodes, right? We can decide how much information we are going to share. And this is called content-based data uses. Consent-based. Consent means I have whether your node has a consent to share this model parameter. If I'm sharing, I'm saying that, okay, for this linear regression, I do not want to share my weights. Then weight will not going to be shared. This is called consent-based data sharing, right? And here, what we are thinking of, no central coordinator, because there is no server, there's no concept of server, and it's the information actually spreading as a chain. Like I have told you something, then that information, I have given you some information, you are spreading the information to others. In this way, information are going to be shared. And the most interesting thing is that whenever we are sharing information using this gossiping, what is the problem in our real life gossiping? The information actually get muted. I'm saying a particular thing, you are actually adding some you are adding some information, that is your version, and you are sharing that information. Means you are trying to modify my information. I have already told you that today this is going to be happen. I have told you. You are adding your version, and you are saying that the new version is actually you have heard from me. So this is the problem of real life gossiping. But here, this is the advantage. Whenever a particular node experienced one AI-based attack, it's actually updated the model parameter. So if X is a node, share its model parameter to Y. If Y gets attacked, then Y will update the model parameter. This updated model parameter going to be shared with Z. So what Z is receiving? Z is receiving mutated model parameter. Z is not receiving the parameter actually sent by X, but it's receiving the parameter actually sent by Y. In this way, we can aware the other nodes that are present in my network about the real attacks, how to prepare them, how to retrain them, right? And if but one node denied to spread the information, there are other different possible nodes that can transfer the information. Now, there is a problem in gossip learning. What is the problem? A problem of trust. Whatever the information shared by the node X to Y, now Y has to believe on that information. Y should have a trust on X. Then only Y can update their information. So how Y can trust X, right? So the problem is here trust. Another problem is there. Another problem is here is called, whenever we are transferring the information, whatever the information sent by X to Y, that information can be tampered. I am observing every scenarios. So there should be a detailed analysis of that. Whenever I'm saying that I am not transferring the whole data set, I'm transferring small amount of information regarding my model parameter. That information is very much crucial. If that information get leaked, if that information is available to the attacker, from that information, attacker can be able to guess something about my data set. So what to do? So before transferring the model updates to Y, I am adding some noise, right? So that if my information get leaked, then using that information, the attacker will not be able to find out the information about my data set. This is called differential privacy enabled dynamic personalized gossip learning. Another thing is that I have another thing that if I share some information with Y, if I have added some noise, then the information get trapped. There's a problem. I'm saying that the attacker will not be able to finding out information about my local data set. But what is the validity of my statement? You can say that what is the base of that statement? If how will you think of that one day, one particular maybe some AI-based node will not be there, attacker will not be there, who has a capability to access information about your local data set from the noised model parameter? That's why we are taking one step ahead. We are actually taking another kind of precaution. The precaution is known as secured multi-party computation. What is secure multi-party computation? Now, in case of secure multi-party computation, what we are doing here, we are actually dividing our data, dividing our model updates into different shares. And we are actually trying to send all the shares individually. So if one share is trapped, then from that share, the attacker will not be able to construct the whole message, right? It's called SMPC protocol. Now, there's the deepfake attacks. We all know that using different deep learning model or generative AI models. The tagline is "Nakli chehra asli khel, suraksha ka ho gaya fail." Here, my article comes about deception game. how social engineering and advanced phishing mechanism can be used to perform this kind of attacks. This is the data set I have used, and the accuracy is this much. It's already depicted in this table. Why I'm showing this information? I'm showing this deepfake information. I'm showing information about extortion because it's right now a problem in our society, right? How data can be manipulated. So the problem is here, though I am talking about different kind of algorithms like federated learning, age learning, gossip learning, the problem is here, our attackers is more intelligent than us. They're designing most intelligent techniques. So what we need to think of? We need to think of an algorithm which has a capability to learn from the situation. That's why I'm talking about gossip-based meta-learning. What is gossip-based meta-learning? Look at here. This is called quick learning from few examples. So suppose I have experienced some AI-based attacks. So my data set is very few. I'm not able to use any classical ML or DL kind of algorithm where I need huge amount of data set. Because this attack is very new attack, I do not have a ready data set for that. So what we can do, we can adapt to new malware. We can detect different phishing, right? Because this meta learning has a capability of adaptiveness. It can adapt across variety of threats. It can transfer knowledge. Suppose I have used some phishing email examples to train my model, but my model can be able to figure out different malware also. That means it's called transfer knowledge from past tasks to new ones. Because we should not be satisfied that I have this solution and this is the ultimate. No. Because every day, new kind of algorithms are evolving. This particular algorithm, what I have talked about, this is meta learning, right? But this is not an ultimate, because I have already raised one question that in our gossip learning framework, we are actually trusting our neighbor. Whatever the information coming from the neighbor, we are believing on that information and we are using that information, right? But what happens if my neighbor get compromised, right? So there is a new one. It's called adaptive trust-weighted gossip mechanism. What does it mean? That means I have some trust factor. So we need to ensure different security models. That means we need to design some algorithm which has some weighted mechanism. We can think of that I can generate some trust score depending upon the contribution accuracy of my neighbor, depending upon the detection of malicious or anomalous behavior of my neighbor, and depending upon the frequency and quality of useful information, right? So using all these things, we can assess some trust so that we can perform prevention. We can prevent some attacks. And this is called adaptive learning because trust score is adaptive in nature, right? And here, our key principle should be that we can believe to a neighbor depending upon his past history, right? So there should be a zero trust and continuous adaptive trust mechanism. Initially, I have a zero trust on you. That's why the rules should be never trust, always verify. So I should have to verify my neighbor using authentication and authorization mechanism. Then we can think of, or we can assume a breach. And for that reason, we can limit the access, that how much information I can share or how much information I can accept, how much information I can accept. And also we can provide different privilege. This privilege should be should restrict the user to access necessary informations and non-binary access. Means that I'm not saying that I'm not receiving any information from you or I'm not sharing any information to you. Rather, I can impose some gradation here. That means I can impose some dynamic access level, right? Now, the problem is that I have a trust on you, right? I've trusted you because after thinking that whatever the updated receipt from you, using that update, utilizing all these updates, I have modified my model and I never experienced any attacks. So you are not harmful. So your trust score is high. So I will accept only updates from our trusted partners, right? But there is a problem. The problem is that I have a trust on you. But you are saying that I have experienced one attack. That's why I have updated my parameter. Please use my updated parameter so that you can be able to update your model, retrain to your model, so that your model will be able to prevent this kind of attacks, right? So depending on the trust score, I'm trusting on my neighbor and I have started retraining of my model. But the problem is that, what is the proof of that? You are saying that you have experienced one attack. You are saying you have updated your model parameter. And you are also saying that if I update according to you, I can prevent this kind of attack. What is the proof of that? That's why I'm saying about zero knowledge proofs. That means without validation, I can't believe on you. I have trust on you, but you should have to give me the proof, right? So here, if you generate a proof using the validation of your model updates without exposing your any underlying data, then I can believe on you, right? So after getting all this kind of proof, now I'll be able to update my model. Next application. The next application is called generative AI-based age invariant face recognition. The tagline is Umar Badli, Pehchan Nahi. Look at here. This particular model, this particular deep learning model can have different application. This particular model can perform image matching with different ages images. That's why it's called age invariant face recognition. So it can also match different facial decomposition. Even if your eyes are closed, it can match. It can match a dead body image with a non-dead body image. Look at the examples. These are my students' photograph, and this is a Sushant Singh Rajput photograph, where we have used the dead body image and the real image. Okay. Why I have shown you this particular example? Because I have a few data. How much image I can gather to do this kind of things. So here I have limited amount of information. I have a few amount of data. I have a few information. As I mentioned, that ML or DL algorithm needs huge amount of data. Otherwise, you will not be able to train your model. But whenever you have a few amount of information present, then what will be your solution? Few amount of information means whenever I'm talking about AI-based attack, you have a few amount of information, right? So using that few amount of information, you need to train your model. How? So this few shot gossip learning will give you that particular essence, when from a limited examples, from a limited samples, you'll be able to learn. And also, you have additional features to adapt a new threads with minimal data. That is the problem right now, because we have a limited amount of examples of new AI-based attacks. You need to learn all these things, and you need to prepare yourself for any kind of zero-day attack, right? So that's why, look at here. Here I have gave one example: fake news detection. I have used here only 3% of my training data to train my model. Yeah, the data set is Cosmos data set. I've used only 3% of my training data. And using 3% of my training data, I have trained my model. So using few data, I have trained my model. In the age of GDPR rules, in the age of DPDP rules, where there is a restriction of accessing the personal data, this few short learning is very essential, right? Now, one step ahead. If I have only one example, means I've experienced one new attack, and only one instance is there in this whole world. So right now, we do not have few data, rather we have only one example, only one data. So is it possible to train your MLDL model using one data? This is called one-shot gossip learning, right? And using this one-shot gossip learning, now what we can do, we can train our model using a single example. Next one. My aim is to prepare my model, or train my model in such a way so that it can resist zero-day attack. I do not know what is the example of zero-day attack because I do not have the signature of this attack. I do not know about that particular type. That's why it's called zero-shot gossip learning, where I do not have any data, right? How it will work? So here we can perform conceptual knowledge transfer. That means we can use some semantic relationship to establish the fact from known to unknown class. That means we need to find out similarity index, or we need to check or recognize similarities in behavior patterns. Also, we can think of attribute-based learning, where we are actually trying to identify what will be the attribute of new malware. Now, again, you could have asked me, you have said that you do not have any idea about the zero-day attack, and now you are saying that you need to think of the attributes of that zero-day attack. Without knowing anything about the zero-day attack, how can I able to just check or think of the attribute of that particular attack? So, deep insight is here. Any zero-day attack or any attack that will be evolved in the year of 2030 or 2035, the one particular common thing should be there, that they are going to use some of your system files. Because until and unless they are actually accessing your system files, these are not malware. If I installed a malware, it's not accessing my system file, so I can install thousands of malwares like that, because it's actually not hampering my machine, my system. So what are the different system files can be accessed by this kind of malware? This is called attribute-based learning. So in this way, what we can do, we can perform conceptual attribute-based and the embedding space, where we can map known to unknown classes using some similarity comparisons. Maybe we can think of some hybrid attack. ransom plus phishing, this kind of attacks. Okay, so in this way, we're trying to identify a new threat without any prior training data. It's called gossip learning. As I told you, that generative AI is a very vulnerable thing. It can be used to design different malware. But I need to explain this, that AI is a double-edged sword. One hand, it can be used for designing different malware. In another hand, it can be used for providing the security. So here, I will give you the essence, how generative AI can be used for crypto security. Now, these are the 4 different kinds of attacks can take place in cryptocurrency. One is called allowance double spend exploit, re-entrancy attack, integer overflow and underflow attack, and front-running attacks, right? So if this is a BSC scan platform, those who are aware of cryptocurrency, I think they know what is BSC scan. If we download any contract here from this BSC scan site, if I save that contract, if I say any GPT that, okay, tell me, is there any vulnerability present in my attack, in my contract? It will check and tell you. Okay, so in this way, we can use that thing. Now, the next part. Now, I have already told you gossip learning using meta learning, gossip learning using maybe zero knowledge proof, gossip learning using few shot, one shot, zero shot. Here, I have used the plain text data. In my initial lecture, whenever initial slides, I have already told you that we need to think of that whatever the data I am actually giving to my ML or DL model, that should be encrypted one. That means machine learning or deep learning should be performed on encrypted data. That should be the motto. Why? Because we do not know that particular model, how can I believe on that model? If I want to run a decision tree, how can I believe on the decision tree? Whatever the code are written, I do not know. I'm just using any Python package. So if I buy some maybe some packages from any vendor, how can I believe on that vendor? I am not doing any white box kind of testing to check each and every line of codes. No. So one thing is that data can be leaked by that model. Whenever the model is actually training on that data, vis-a-vis, it can leak my data. And the thing is that whenever you are actually presenting your patient data to any machine learning algorithm, what about your data privacy? What about the HIPAA Act, HIPAA? HIPAA Act, when you are saying that I am not authorized to use my patient data, you are saying that thanks to the federated learning, thanks to the gossip learning, we're not sharing our data to the central server. But you are actually using their data for analyzing purpose, for you are using some data, their data for analytics. So here, what we are doing, we are encrypting the data set. And then we are performing this kind of gossip learning on the data. Right? So look at here, look at the situation. Any financial institute, any healthcare institution can encrypt the customer data. And they can use gossip learning. They can say that, okay, I have a encrypted data set. I'm not sharing my data set with my server because I have a concept of server. I can use any machine learning or deep learning algorithm on that data. Data is encrypted. So there is no problem of security. ML model will run on encrypted data, and it will give you the result, maybe some prediction, maybe some insight. The result, the prediction, whatever the generated by the email model that also will be encrypted. So the vendor's email or DL model will not be able to understand on which data the model is actually operating and what is the actual output of that data, right? What is the actual analytics result? That encrypted result is actually being transferred to the customer side. And now the customer has a key. If the patient has a key, encryption key, using that encryption key, now he or she can decrypt and get the actual result, actual prediction result. So in this way, we can perform encryption technique. Now I have another question. That what is the trust? What is the trust factor of the encryption algorithm? We are thinking that, we are saying that AES, DES, triple days, or maybe different new kind of algorithms. All we know the algorithms, we know the steps, only things that actually secure the algorithm, that is the key, right? So if key is known to anyone can decrypt that one. So here, there should be a mechanism where key should be unknown as well as the encryption should be unknown. What does it mean? I am not going to use any existing encryption technique. I'm saying again, I'm not going to use any existing encryption technique. Rather, encryption technique will be developed at runtime. Encryption technique will be developed at runtime so that I can prevent different kind of attacks. The attacker will not have any kind of clues what going to be my encryption algorithm, what are the different steps, what mathematical processing we are using in this particular session. And in next session, we are using again a different encryption algorithm. So encryption algorithm is actually designing at runtime by two neural network. This is called neural cryptography. Okay. So here the example of the previous technique where we have used encrypted. Look at the screenshot. The first CSV file is a plain text data set. It's get encrypted, and the right side corner, up corner data set is an encrypted data set. We have actually run our algorithm on this encrypted data set, right? So the solution is Ganga, using the name of Ganga, security and purity. It's called gossip learning based adaptive network generative encryption. The tagline is N in encryption का मजबूत जोर है टूटेगा नहीं. Why I am saying टूटेगा नहीं? Because किसी को तो मालूम ही नहीं है encryption technique क्या है यहाँ पे. That is the beauty of this technique. These two bots or these two neural network will be able to generate their weights so that they can synchronize with each other. They can generate the encryption technique. This is called autonomous learning. So using this autonomous learning, they can create robust encryption system. And also, here we are actually how these two network will design the encryption technique, how they can think of that, okay, let's chalo ye design kare. Let's design this one so that the third party will not be able to understand. To make the attacker lives difficult, we are considering the advisory situation. We are placing different advisories, different advisory neural network. We are ready to sniff the data packets. In that environment, we are running this two neural network. And This neural network is actually updating their weight, updating their mechanism to generate a new cryptographic algorithm using their mutual learning. The learning is known as mutual learning. And they have a dynamic adaptation facility. So here, encryption evolves as sender and receiver adapts to eaves, means attackers, attempts to break it, right? So this is a code snippet where Alice and Bob are the two sender and receivers. Here, Eve is a attacker. The Eve loss should be maximized, maybe 99 point something, 99.9 here, so that if Eve loss is maximum, then data leakage is minimum. So what is the takeaway? The system auditor should have to know. The system auditors are there who are trying to audit your AI ML system. That means your AI ML system, whatever the system you are using, it's actually protected. It has a sufficient protection. Whatever the website you are using, it's a protected one or not. They should learn this kind of cutting edge algorithm. The ML is old. DL is old. I have already talked about what is new, right? The CISO and CISO or CTO of any company should know what should be the strategic overview of this AI and ML role in cybersecurity. And the chief, this processing officer, CPO, due to the GDPR Act, every company should have a CPO right now. So they should have a detail of how to prevent this kind of attack, what will be the privacy regulation, what will be the security attributes, this kind of things. Okay. So I have already talked about a lot of attacks. I've talked about a lot of different kind of algorithms, right? So I think we need to conclude here. But before conclusion, picture abhi baki hai. Just wait. Look at here. What is AI-based attack? Last 1 or 2 minutes I will take to conclude my session. I've sent you one file, maybe a zip file, maybe an image file, maybe a PDF, maybe a Word, any kind of file in your WhatsApp. You have just downloaded that. Look at here, the right side scenario, you have downloaded the file. It may be a Word file. You can open the Word file or you can open the image. I can get a complete access of your dashboard. You may using Windows, you may be using iOS or maybe Android. Look at here, not detected by antivirus. Okay, look at the date here. So this particular files is not detected by any antivirus. Okay. Now here, not detected by any Defender also, Windows Defender, Windows Security. Here we are using Windows 11, right? I request you to see the system date. It's 17th of this month, 17th November. So this is a very new. So here, virus, all the virus protection are there, Windows Security, saying that Microsoft Defender antivirus scanned your device, no new threats were found, right? What I can do, I can remotely access your system. I can take screenshot of your system. Look at here, I'm actually in the screenshot of your system. I can download any file from your system. Not only that, I can turn on your webcam, but your flashlight will not going to on. So your flashlight will be off. So you will be not aware of that your webcam is on, and I can take picture of yours. This is my student's picture. I can delete the file. Whatever the file I have sent you through WhatsApp, I can delete the file so that I can delete the digital footprint. And whenever I'm saying delete, you people may think of that. Delete means in our computer system, in any hard disks, we are saying that you can't delete anything because there is a digital footprint. Deleting means we're actually removing the pointer. So deleting means here, I should have to delete the file and I can put at that location of the memory some garbage file. So I'm replacing the original malware file with a garbage file so that you will not be able to understand using different scanning or forensik tools that this particular image or PDF or Word documents is actually responsible for performing this kind of attack. So if you open an image, open a PDF through your WhatsApp, you get compromised. You can upload any file to that particular system from your system. You can read any arbitrary file. You can execute any command. You can towards any directory. Look at here. And also you can escalate the user privilege. Look at here. This is the WhatsApp snapshot. You can also perform your WhatsApp as your control board, as your dashboard. Look at here. Whatever the command I have written here using the WhatsApp or Telegram, right? You can snatch all the permission or all the passwords saved in their browser. This is the code. If you this password is actually saved in login.data file, you can open that one using simple Python program. Not only that, if you transfer that particular image PDF to anyone's, then his or her machine also will be in our dashboard. So I can handle multiple clients at a time. Look at here. Here, 3 persons are actually have already opened my picture or PDF. Client 1, client 2, client 3 can access them. Right? I can execute any command. I can switch between clients. And also I can access, download, I can turn on the webcam. Even if whenever you are typing anything, maybe your CVV that is not visible here, I can get that CVV from here. So what is the solution? The solution is do not use the internet. Do not use internet. Otherwise, it will be a problem. A layman can be think like that. I have a solution for that. Look at here. Here the heading is called exfiltrate data or keystroke from offline device. If your device is offline, look at here. The first screenshot, Wi-Fi is not connected. Bluetooth, everything is off. So device is completely offline. Then also I can hack your computer by capturing the signals. Whatever the key are you typing, I can take that signal. So stay alert, stay safe. For any kind of problem, please dial 1930 or log in your complaint in cybercrime.gov.in portal. Thank you. Thank you very much.
Hello. Thank you very much, Dr. Arindam Sarkar, for your enlightening session. Now we are open to take questions from the participants. So you can type in the chat box your questions, or you can use the mic also to ask anything to Dr. Sarkar.
Look, you can ask anything.
Kindly type your questions and I can read out to sir.
Hello, sir. Am I
Yes.
audible?
Yeah. You're
Sir,
audible.
actually, you are telling one of the slides that you had been using only 3% training data.
Yeah.
Sir, is it possible to use that percentage of training data and we can get good results or
Yeah.
good
Yeah.
accuracy results?
Yeah. So this is called few shot learning. In that slide, I have shown you the 3% of training data. Now, in few
Yes,
shot
sir.
learning, the way you are thinking in machine learning algorithm, the way you are actually using your data to train your machine learning algorithm, we are not using the same way. That means, suppose I want to, when I was in my college, I didn't learn Python, right? So I learned basic C, C++ kind of language. Even I didn't learn Java. But when I started learn Java, how much time I took? Maybe 3, 4, 5 days? Because I had an experience. Same way here. Whenever you are training any algorithm, then the algorithm is being trained maybe on phishing attack. Whenever a new attack is actually coming, I have very few examples of that attack. So my algorithm is trained on previous data, on historical data. In such a way, again, I'm saying in such a way that training algorithm should be differ from the classical ML algorithm. Such a way so that it can adapt a new features. It can train a new features using very few examples. That's why I have talked about attribute-based learning. That means we need to find out the similarities. What is the similarities between malware, virus, worms, maybe spyware, or maybe ransomware? If we find out the similarities, then if we learn the similarities, then we need very few example for training data.
Okay, so we have received another question. What are the scalability limits of gossip learning in heterogeneous networks?
Yeah, the heterogeneous network, the thing is that I have already told you the ML for all devices. Suppose I have a smartphone with limited power capacity. For that smartphone, I need to think of that what type of tasks I should assign to that particular node, to particular smartphone, to particular edge device. Because I'm thinking that this device does not have this much of power to prevent the AI-based attack. One problem is that how to prevent the AI-based attack. So here the scalability is that we can use your smartphone, we can use any server, but before using that, we need to segregate that what kind of tasks I should assign to a particular machine which is vulnerable to attacks, right? So in this way, scheduling, the task scheduling algorithm should be there. And if I think of that how much information can be leaked if that much of data get compromised, all these particular planning should be there, then I can say that you can scale the machine gossip learning, right? So without proper management, you can't use this gossip learning or any kind of learning, because you need to think of that which tasks can be performed by which device, what is the power requirement. That's why I have shown you one screenshot of code where before accessing or assigning any kind of tasks, first and foremost task should be to check the resource availability of that particular machine.
Okay, sir. Another participant is asking, could you suggest online resources for this particular domain?
Is very new. It's a very new one. You can follow some of the research paper published in this 2024 Elsevier. Okay, because right now this gossip learning is very new. That's why I can't suggest any book or any online YouTube lectures video on that.
So there is another question in gossip learning, how the data can be collected. Is it from the internet chatting?
No. Data, it means suppose in my smartphone, I have data, I have some pictures, I have some WhatsApp chats. So data is not being collected. Data is there. That's why I'm saying that local data. Whenever you are saying collection of data, then the question comes the data privacy and the DPTP Act. Who gave you the data? Where from you have collected the data? That's why the data is my data. My date of birth, my name. I didn't collect it anywhere. This is my information. So every device has some information. In machine learning, what I'm saying that device, whatever information available to you, please send it to me. Server is saying that. Here I'm saying that no, keep your information in your site. You do not need to transfer your information. So whatever your personal information, you haven't yet gathered anywhere. It is your information. So keep it at your site. I am just placing one machine learning model to you. You please use that machine learning model on your data, right? So there is no technique, no such technique of gathering data from internet or anywhere. It's your data, your system data, or your surfing history, browsing history, like that.
Okay, sir, there is another question. What is the training model or algorithm we are using for the gossip learning? How we are getting the data to train?
Simple. Here I have talked about the protocol. Here I am not suggesting any machine learning or deep learning algorithm. Whatever the machine learning you have used, the same machine learning algorithm, supervised, unsupervised, semi-supervised, maybe every ensemble learning, deep learning, all the models available. You know the algorithm of that model. You can use that model here. But how will you use that model? That is the protocol. The gossip learning is saying that whenever you are using decision tree or random forest, how to use the decision tree on that data. But the very principle of decision tree is same. The random forest is same principle I'm applying here. But whenever I'm applying that particular algorithm on that local data set, whatever the accuracy, precision we are getting, we are not sharing that with anyone. We are keeping that information locally. That is the protocol. That is the rules and regulation. So I'm talking about the rules and regulation. I'm not talking about new machine learning. I'm not proposing advanced decision tree. No, whatever you are proposing, advanced decision tree or the classical decision tree, all are there. But how to use that particular ML model in gossip learning, I'm saying all that thing. Only you need to send the model parameters to your neighbor. So this is gossip learning. Here, everything is old. That means machine learning model, you're using old machine learning model, but in a new structure, in a new way, using new regulations.
So there is a request to share the PPT from the participant.
The problem is that this PPT, I can share that one, but I can't share the current form because it actually contains some maybe some vulnerable information regarding hacking. So I can share the gossip learning information with everyone, but the hacking code can't be shared due to the content policy.
Okay, sir. Okay, so today we will wrap up the session for now. Thank you very much, sir, for your tremendous session. We're already receiving very good feedback. Thank you very much for your time.
Thank you so much.
Our next session will resume at 2 o'clock. We will open the link few minutes prior. Please join us for the second session of the day. Thank you.